Alrighty, good morning. Going to kind of go over a little bit about your outline that you did the other day. So we're talking a little bit about minerals and rocks and things like that. So we'll go ahead and get started. What minerals are? They are naturally occurring inorganic molecules. The main thing about minerals is that they have a very set specific crystal structure internally, which is important to note because there are things called mineraloids that look very much like minerals, or they're inorganic, they're naturally occurring, but they don't have a set crystalline structure, and so that's what makes them mineraloids and not minerals. They've also got a definite chemical composition, and your minerals are going to combine to form rocks. So they're the building blocks for rocks. Okay, there are two main groups of minerals. There are the silicates and the non-silicates. The silicates, like their name says, they're going to contain silicone and oxygen, or silicon, sorry, not silicone, silicon. They're a pretty large group of minerals. They're going to make up about 90% of what we know as the crust, the continental crust. So they're going to make up most of our rocks. So on the flip side, you have non-silicates, which are a little less complex than your silicate minerals. The other thing that's interesting to note about these guys is that they don't have, well, I guess it's not that big, but it's kind of obvious when you have a non-silicate, it's not going to have silicon and oxygen structure. So they're going to lack that. That's why they're called non-silicates. So there's a couple of special groups. The first group are the oxides. They're going to contain oxygen, but there's not going to be silicon. They're going to have a positively charged ion, which we call a cation. So we've also got carbonates, and these guys are going to contain carbon, like the name implies. And then the last group are the sulfides, which are going to contain sulfur. So pretty simple so far. So they're all going to contain that cation as well. Okay, so by the way, there are a couple of different other smaller groups of non-silicates that you can have. So, but I just named the three big ones. So, okay. When you identify minerals, it depends on who you ask. There's anywhere from 6 methods or 6 properties of minerals to as many as 10 to 12. It just depends on what you call a physical property, and then sometimes people will call some of the physical properties special properties, but sometimes those same things are going to be called, regular physical properties. So it really just kind of depends on who you're asking. But okay, so the first way, and this is in order on your little sheet. So the first way that you can identify or one of the physical properties of minerals would be through color, which fairly self-explanatory. It's just what color the mineral can appear to be. Now, your color of your mineral can change, can be different colors or it can be the same. It just depends. So sometimes they appear one color, sometimes they appear different colors, and that can be due to a multitude of things. It could be due to different chemical compositions that can be made, due to chemical impurities. So of the physical properties that we're going to talk about, this is the least reliable one, just because there are so many different variations of color. So it's kind of hard to be like, there are several that are going to be gray or have brown specks in them. So it's not a very reliable way to classify your mineral or to identify it. The second way we can identify your minerals is by luster, which is a description of how the mineral is going to reflect light at the surface. So if it reflects light, kind of like a metal, and it reflects it very well, we tend to say it has a metallic luster. If it does not, if it's transparent or sorry, if it's opaque, then we tend to say it is non-metallic. Now the difference between translucent and opaque. Translucent materials are going, you can kind of see, you can see light through it, but you can't really see anything else. So it's almost like if you had a sheet up and you put a light behind it and you had two people standing behind there, you could see their shadows. So you could tell there were people back there, but you wouldn't be able to really see their physical features. But you could kind of see some light shining through. That would be translucent. If something is opaque, that means you can't see through it at all. So for the most part, walls are opaque. You can't really see through walls. And then transparent would obviously be, you can see all the way through it. So, sorry. In order to be considered a non-metallic, you have to be opaque. So you can't really see through. There's no, that's one of the characteristics, is you can't see through it. So there's a couple of different terms that we can use to describe a non-metallic mineral. One way is vitreous, which is glassy. If something is brilliant, it would be adamantine. If it looks like it came from a tree sap or something like that, we would call that resinous. If it looks kind of waxy, it might be silky. And then if it looks kind of like the inside of a seashell, kind of pearly, we would call that pearly or iridescent. And then the last one, if it kind of looks dull or dirty, we might call that earthy. So those are descriptions of non-metallic minerals, how we would describe those. So those are two ways. We've got a few more. We can do streak of a mineral. So when you are determining the streak of a mineral, you actually use these little things called streak plates. They're usually small, almost kind of like tile clay looking things, and you basically just take the mineral that you've got, and you kind of pretend like it's a piece of chalk, and you try to draw out a little line so you can see what color that streak is. So it's what it leaves behind is just the powdered form of the mineral. So that's basically all the streak is just what color is the powder. Now the interesting thing about the streak is that despite the chemical impurities, despite the different colors of a mineral, the streak color will always appear the same color. So it doesn't matter what colors the mineral looks like, the streak will always be the same color. Okay. Cleavage. This is another. So this word and the next physical property, fracture, they both mean how the mineral breaks. The difference is when you're talking about cleavage, you're talking about how does the mineral break along a smooth, flat surface. So how does the mineral break along the smooth, flat surface? Okay. Usually it's going to break for both fracturing and for cleavage. They're going to break along certain points of weaknesses in the structure of the mineral. So weaknesses in the structure cause them to either cleave or fracture. Or since we're talking about cleavage here, it's like I said, it's a smooth, straight break. So let's see if I can pull this up. I don't know if it'll let me. Um, so let's see what you're looking at. Nope. Okay. So let's. Okay, I'm gonna switch my screen share. Okay, so I think maybe. I don't know. Here, I'll do the entire screen. I'm not sure why it's not letting me do this. Well, now it's showing me a whole bunch of stuff. Okay, so here, let's do this. I'll insert this into the slideshow. We'll do it that way. Okay. Maybe. Here it is. Okay. So this is kind of what I was talking about. Sorry, that took me a lot longer than I thought it would. It was easier to do on the Chromebook. Okay, so this is an example of galena, which happens to be Missouri's state mineral. I have no idea if Italy has a country mineral. I honestly have no idea. So that's something you could look up to see if your provinces have different minerals. I know here in the United States we have state birds and state trees and state flowers and things like that. So it may just be an American thing, but in the state of Missouri, this is our state mineral. So, um, so anyway, but you can kind of see what I mean by breaking along a very straight, flat surface. Galena is a prime example of breaking along a straight surface. I mean, it naturally, no one carved this, it naturally breaks in these straight, cube-like shapes. So that's galena for you. It can break in one direction or it can break in more than one direction. If a mineral breaks cleanly and easily, we tend to say that that means it has perfect cleavage. So I think that's your last little thing on this slide, on this portion of cleavage. So if the mineral cleaves or breaks easily and cleanly, the cleavage is considered perfect. So, okay, so there's our side thing of galena. All right, the last three major physical properties that we're going to talk about are fracturing, which I kind of talked about. It's, again, we're talking about how a mineral breaks, but what we're specifically talking about is how it breaks along a curved, irregular, or jagged way. So it's not going to be that straight, flat break like we saw with the galena. Okay. So, so unless it looks nice and straight and perfect like that, it's going to be considered a fracture instead of a cleave. Another one, another physical property of minerals is hardness. So how hard they are. We measure this using a specific scale called Mohs hardness scale. It's a scale from 1 to 10, 10 being the hardest, 1 being the softest mineral. The softest minerals you can generally scratch with your fingernail, and you'll be able to scratch stuff into a powder form. The hardest ones you won't be able to scratch at all unless you scratch it with itself. So the softest mineral that we know of is talc, Talc. And then the hardest mineral that we know of is a diamond. So in order for jewelers to cut diamonds, they have to use diamond-tipped blades, because what they, trying to cut it with a normal knife or a saw or something like that is just not going to work, because the diamond's too strong or too hard. So that's one way. And then density, which is sometimes called specific gravity. This is just how much of the mass of the minerals per unit of volume. So how much space does this particular mass take up? It's a measurement of how close those molecules in the mineral are. If they're really, really close, we say they're dense, and so they become heavier. If they are further or spread further apart, then we tend to say that they are less dense, and so they would typically float. So, okay, there's a couple, I told you a little bit, there's a couple of special properties that sometimes we'll use to identify your minerals. The first is effervescence, in acid or radioactivity. That just means that if you put a little drop of acid on that particular mineral, it will bubble and release gas. A second one is radiation, and then this one means that it's radioactive, so it usually contains uranium or plutonium or something like that. Radium. The third one is fluorescence, which is the ability for a mineral to kind of glow under ultraviolet light. So it gives off kind of a glow under UV light. A fourth one is taste. When we talk about taste, we're talking about sometimes they have a saltier taste. Sometimes they usually it's salty. I'm not gonna lie. Usually it's salty. So that is one of the ways you can identify a mineral. You can also be magnetic, so the ability to attract iron, which would be magnetic. And you can also have the ability to form a double image, which would be an optical property. So this kind of gives you an idea of the different ways to identify minerals and what they are. I think tomorrow what we're going to do is we will talk a little bit about rocks, the different types of rocks and things like that. So this seems like a geology class, and it basically is. So if you find out that you have other things besides just the silicates and non-silicates, let me know. This will be a fairly short chapter because I don't want to go too terribly in depth since you probably don't need it, and we need to move on, I think, to your human body. So if you do have any questions, let me know. I don't need this outline back. It's for you to study off of and use. So, so yeah, I'm probably looking. Oh, probably Friday, maybe Tuesday. Looking at giving you a quiz over this stuff. It'll probably realistically be more like Tuesday. So, um, so yeah. But like always, if you have any questions, just let me know. And have a good day.